virtual run. Been teaching on and off for about 20 years. I also have a career as a computer programmer. Any of you are CS majors? And oh, okay. And you ever want to come talk about that career path during office hours or whatever, you're welcome. I've been doing math for over 60 years. I really love it. And I know not everybody has learned to love it. It's hard. It's not for everybody, but we do need it. The important thing for my class, unfortunately, is you learn to spell my name, because you'll find I have a website. Okay, and you're at USF, and you're Math 104. At my website, you will find my syllabus, which I suggest you take a look at. Let's see. You're going to have office hours at least every Tuesday and Wednesday, starting 11:30, 12. I'll probably be hanging out there until this class, except for lunch. You're welcome to stop by. If those hours don't match your schedule, you're welcome to contact me. We could either do a Zoom conference or meet some other time. I'm in office 119E Hardy. You can look that up on the syllabus. All right, what else can I tell you? So at this site, you're going to find my lecture notes. So if you miss a lecture, miss a class, you can go look there. I'm also going to try, that thing working? Yeah, it's working. Aha, your name is?
Jack.
Jack. Nice to meet you, Jack. Have a seat. I'm also going to try and put links up to videos that I make of the class. Again, we live in difficult times, and for no fault of your own, we might not be able to come to class. You might have to stay home and get well and avoid passing things on to us. I'm not going to do this today, but in the next class, you're going to pick a seat that you want to stay in. The reason for that is not that we want to do that, but in case we have to do any COVID tracing, you know, if somebody gets sick or is in contact with someone, we want to know where people are sitting so we can contact you. So today is fine, but next session, pick your seat carefully where you want to sit. Other things that will be on the website will be homework assignments. I'll announce them here. I also will post solutions to homework assignments. And there's some sections there on problem solving you might want to take a look at. Might be some helpful hints. Okay. I'm just going to make a brief comment. Some of you may be first-year freshmen. New environment, a lot of things to get used to here. I've been teaching a long time. I've taught in high school. I taught briefly in a grammar school, and I know that there are different attitudes about honesty, right? The standards here are very high. We expect the best of you, and we expect that you're gonna be honest and have integrity. Where that comes in this class is very simple. When you do homework, I encourage you to work with other people, right? Learning math can be very helpful in a social environment, but when you turn in an assignment, it has to be your assignment. Please don't, meet up with somebody, copy their homework and pay for it. There's no point. I'm not real strict about turning stuff in on time. I want you, reason for homework, it's not a big constructive part of your grade. It's for you to get practice and to learn. So please, keep that all straight. Obviously on a midterm and the tests, the work has to be your own. So, okay. So for this class, I've taught this class before, and I don't mean to impugn anyone here, but the question comes up in my head, why are you here? In the past, I've had students who are taking this class who, they're really overqualified. They say, hey, I can get I need a credit, I can do something easy. I had a student that passed calculus and was taking this. Now, that's fine if that's what you want to do, right? It's a very expensive school, but if you're in that situation, I encourage you to reconsider. Otherwise, everybody's welcome here. We're all going to do our best to learn the subject. What else do I have to say? I was going to also say, especially to the first year freshmen, adjusting to college, your first semester's a big adjustment for many. It tends to be a lot more work than you're used to, can be very intimidating. And I want you to know there are a lot of resources here to keep you out of trouble. This college is unique in that matter. You have a counselor you can talk to if you're just feeling overwhelmed. If you need some help with some area in math, right across the way we've got the library. You can go in there and talk to them about tutoring if you feel you need some extra tutoring. I'm happy to talk about anything in my office hours. If you want to talk about your background in math, how to get some skill, you should feel free. You can come talk to me about that. Okay, I want to throw out a few kind of basic rules in my class. I already mentioned the seating. We'll do that next time. Obviously, try to come to class on time. If you're late, just come in quietly. Don't make a big deal about it. It's no big deal. If you need to keep your cell phone on, please put it in silent mode. I mentioned homework. I'm pretty flexible about that. I want you to learn from it. But, if you can't get it in on time, don't panic. But don't abuse me, please. Don't hand in all of your homework the day before the final. Yes, and I can't help but laughing. It's happened more than once. If you need to step out and use the restroom, you need to leave class early, don't make a big deal. Quietly go out, and we're all adults. No big deal there. That's kind of it. Before we get going with the fun stuff, are there any questions? Okay. So, does someone want to tell me what a prime number is? Does anyone remember what a prime number is?
Is it the one that can't like be divided by anything?
Well, it can be divided by something.
Yeah.
It can only be divided by itself, right?
Yes. And one other thing can always be divided by 1. Yeah. Okay. My apologies. Oh, also, because my phone is in use recording this, I don't have any way to check the time. So if someone could give me like a 5-minute kind of warning when the classes are almost over. Okay. Someone tell me what a composite number is? Okay. Composite number is just the opposite of a prime number, right? So if we have prime numbers like 2, 3, 5, 7, their factors are just a number and 1. But, you know, 4, 6, 21, these are all composite numbers. Okay, so now we're going to get very highfalutin here. We're going to talk about the fundamental. Whenever someone says fundamental, you want to perk up like, hey, maybe this is important. Fundamental, why is this important? Theorem of arithmetic. Well, let's take a number like 30 for a second. So if I try and think of the factors of 30, you say, well, get a factor of 2 in there, right? At least 15. So 3, 5. Okay. You might have at one time thought to yourself, I wonder if there's any other way to do that. I mean, I know, like you could divide it by 10. Oh wait, 10, that's 2 times 5. Okay, it's the same. Fundamental theorem of arithmetic says that given any integer, think about integers now, or natural numbers, we'll get into that in a second, there's only one way to find its prime factors. Well, that's nice, because that means when we're trying to find the prime factors of some number, we can do it piece by piece and we know we'll end up with the right answer. We're not going to end up in 2 branches and we're going to get different numbers. So this is a really, this may seem very basic, but this is a really important skill to be able to take a number and break it down. For small numbers like this, hopefully this is pretty easy, but if I put some number like, I'm just making this up as I go, 564, well, it's probably what its factors could be. How can we figure that out? So there's this skill which I'm sure all of you have some background in, which is what we call divisibility tests. I guess I'm going to write them over here out of the way. And these are going to get us through most of the work quickly, easily, right? So the first divisibility test is the divisibility test for 2. And I don't think I need to even ask. Everyone knows you have some number. You look at the last digit. So the last digit is divisible by 2. It's divisible by 2. So in this case, we know this has to be divisible by 2. You can kind of, okay. Well, it seems like we run out of room here with the divisibility 2 test. This is odd. It's an odd number. It'll never be divisible by 2 again. So that's that. Next divisibility test is 3. Anyone know divisibility test for 3? Remember this? I'll give you a hint. It's just like the test for 9. Well, it stands to reason if it's divisible by 9, it's going to be divisible by 3. Anyone know this test? Okay. Well, the test says add the digits. Let's add the digits here. 1, 5, 7, 14, 19. And when you get to 19, if you want, you can add those again. 9 plus 1 is 10, and 1 and 0 is 1. If the number you end up with is divisible by 3, it's 3, 6, or 9, the number is divisible by 3. If it's not, it's not. So here we go, it's not divisible by 3. Just pick a good one. Okay. 4. No. Divisibility test. 4.
Kind of be like the same. Like if it's divisible.
I would say exactly the way you said it. It's kind of like the same.
But
Let's think about it for a minute. Think about 18. You know it's divisible by 2. It's not divisible by 4. So it turns out that if the last 2 digits are divisible by 4, then it's divisible by 4. Okay, so I'm going to say here, check last digit. Check last 2 digits. Okay. Anyone want to venture a guess as to what the divisibility test for 8 would be? Any guesses?
check the last 3 digits.
It's take the last 3 digits. You got it. Now, at that point, you could go on. You could say 16, check the last 4, 32, check the last 5, but it's not very useful, and you're not going to need it. At a certain point, you know, you just haul out the calculator, right, and find out. Right? Okay. Now this is like the easiest one. How do you know if the number is divisible by 5? Yes?
If it ends in 0 or 5. If the number ends in 0 or 5.
The number ends in 0 or 5. Okay. Okay. Now, there is a divisibility test for 7. Don't try and remember it. It's not very useful. It's hard to understand. It doesn't make a lot of sense. I'll show you in a second why all these other ones make a lot of sense. But here it is. Remove the last digit, multiply it by 2, and subtract it from the number. Repeat until you have just one digit. We got to try it here, don't we? So we remove the last digit, multiply it by 2, subtract. Repeat it. Remove 1, run out of room here. We can't subtract 18 from 13, so we're just gonna have to look. 7 into 13, that's gonna leave what? 669. 69 divisible by 7? Clearly not. 70 is divisible by 7. That's not very useful. If you have a long number and you want to know if it's divisible by 7, call out the calculator. These numbers, these will like serve you really well down to like any number below 121. And okay, so I'm harping on this. It seems very basic. Why is this useful? Why is this useful? Not, in this class, but in future math classes and other classes you're going to take. This is all about having good facility with numbers, right? In order to do advanced math, you're dealing with very abstract ideas, but if the real numbers get in the way, you don't see what's going on quickly, it gets in your way. So that's why we're learning these. Okay, so that's okay. I want to say, I think, the way this class is designed, it's going to start off pretty basic, hopefully pretty easy. It's going to get harder, and it's going to move fast. So if you feel like comfortable now, great. If not, you're going to have to do a little work. But be prepared for it to get, to move quickly and get more difficult. Okay, I'm going to suggest something. I can't make you do it. But I'm going to suggest that there are a few other numbers that are good to kind of have in your head, right? In particular, the squares of numbers, right? If someone asks you to count by ones, that's easy. But if they ask you to count by squares, you probably have to kind of think for a second. It starts out easy. And then it gets a little trickier. And you probably know all the numbers after this, but it's good to recognize them as squares. It comes in very handy. And I'd also recommend that you go a couple steps further. It's good to know 11 squared is 121. That way when you see 121, you don't think, what's that number? What's it divisible by? You think 11 squared. Same thing with 12 squared. Here's a piece of trivia. 144 has a name. It's a unit that we sometimes use. Does anyone know what that is? You probably haven't run into it much. It's called a gross. And some things you sometimes buy in gross. Like, anybody think of something you buy a gross of? Okay, that's fine. Pencils. Pencils come in a gross, 12 by 12. 15 squared turns out to come up a lot. It's nice and useful. And since at least someone said, more than one person mentioned computer science, especially useful is 16 squared, which is 256. All the numbers with 2's are useful for computer science people. You know why?
Because
It's a binary, that's right. So here we've got 16 binary bits, that's 2 bytes, right? 256, that's, how many bits is that? Well, it's going to be 16 and 16, 32. No, that's not right. That's totally wrong. What was I thinking? 32 bits is, it's about a billion. It's good to know that. All right, I'm going off on computer science. I shouldn't do that. Okay, so with this basic information, I want to develop a strategy for breaking a number down to its prime factors. Now, this is a little orthodox, but when you're first learning something, it's sometimes helpful to do it in an orthodox, very, algorithmic manner. Right? So let me try the number 30. I want to find its prime factors. And so I look at this and I have to find, it doesn't matter where I start. I start with my list and just go down the list, or I can just start to think, well, what do I know the factors of 30 are? Right. Well, so I'm going to guess 5 and 6. Then I look at each of these two numbers and I say, what are their prime factors? Well, 5 is prime, right? 6 is going to be 2 and 3, and those are prime. So now I have my prime factors. Let's try another one here. Try 84. Okay. Someone want to give me a couple factors? Okay. Anyone? Yes?
4.
Okay, 4 and
2.
I'm sorry?
4 and
Well, 4 into 84. 4 goes into 8 twice. Goes into 8 once. That's 21. Okay. If it's hard for you to do some of this stuff, like completely understandable. It's completely understandable. This is like, it's like bicycling, when you first start trying to do it, you fall over because you don't have balance. But this is actually valuable stuff. It's just very basic. All right, how about 21? 3 and 7. Okay. All right. Now we're going to go through kind of a mundane exercise here. We're going to think about the numbers that aren't composite for a minute, and we're going to try and write them all down. Right? It's not going to take long, but it's useful to know which numbers look like they're prime but aren't, that look like they're prime and are. Right? So to start off is real easy. I'm not going to go into the details because we had an argument the other day. Why isn't 1 a prime number? It's irrelevant. It doesn't have any use. But for the moment, 1 is not a prime number. So we have 2, 3. Now we know anything that is like 2 is not prime. Same thing with 3. We skip 4 and we go to 5. That takes care of all the 5s. Anything even, right, isn't going to work, so these are all going to be odds. 7. We get to 9, but we know that's 3 times 3, so that doesn't work. 11. 13, 15, 15, 16, right? Oh, 17 is the next one. 19. Everybody can do that pretty easily. Then we get things get a little trickier. All right? 21, we know. Oh, we saw that's not. How about 23? 24, no. It's even. 25, I'll just skip the evens for now. 25, obviously not. 27, oh, 27. Well, 2 plus 7 is 9. Fails the, you can leave it right now. And it is. Okay, so now we're up to 31. 32, 33, that's easy. It's 11, right? 34, no. 35s are out. Actually, at this point, only things with a 3, a 7, or a 9, right? These 2s, 5s, right? Okay. I have to look at my paper because up here next to the blackboard, I'm kind of dumb. It just happens. You ever had a teacher tell you that? No? Okay. All right, let's look at 40s. 41. Well, we add the digits. No, it's not 3. How about 7? Well, actually, 42 is 7. Divisible by 74 times 6, so it's not going to work. 43. That's another one. 47. How about 51? Oh, wait, 5 plus 1 is 6, divisible by 3, right? 53. Oh, I don't want this one. 53. 59. There's only a few more left. I'm just going to jot them all down. 61. 57. 83. 89. Oh, 97. One of the ones that periodically tricks me up is 91. It looks like it should be prime, doesn't it? And then you divide it by 7, and you get 13, 7, 13. So that's kind of a hard one. 91 is a hard one to kind of keep off this list. All right. Why is this useful? Why is it useful to know these numbers? Well, sometimes you're doing some algebraic manipulation and you're trying to reduce it, and you're trying to reduce those numbers, and maybe there's some common factors. But if you recognize the prime numbers, it's like, oh, I'm done. I'm not going to be able to factor that anymore. Again, I'm going to have my phone next Thursday, but can someone give me a time check?
318.
Okay. All right, so let's at least apply this now. This is really useful when we go about trying to reduce. So let's take an example. Can I reduce this? Oh gosh, I don't know. If I break it down to its prime factors, it'll become really obvious. So let's try here. 72, right, well that's going to be 2 times, see if you can do this in your head. Okay. 72 divided by 2. 2 goes into 7 twice. 36. Okay. Let's write it a little here. 36. Oh, okay, that's another 2, right? Divided by 2. Well, there's different ways you could do that. You could divide the 30, that's 15, and the 6, that's 3. You add them together and you get 18. Or you can write it down on a piece of paper. Nothing wrong with that. I encourage you to not go for the calculator right away. Because then it's like me and the GPS. I used to know my way all the way around the world. Now I got a map and I can fill in. And now, geographically, I'm an idiot. I just call it GPS where to go. And that happens. And with the GPS, it's okay, because I'm not a navigator. But in math, you really have to feel this in your bones. Okay, so 18. Well, 18, can you see that right away? 18, 9 times 2? 3 times 3. Okay, those are my prime factors. Now, 87, I don't know what to do with that right away. Let's add the digits. 8 and 7 are 5 times by 6. It's got to be divisible by 3, right? Okay. 3 into 8 goes 2. 3 into 27 goes 9. Here's where knowing the prime factors comes in handy. Did I not write down 29? I can stop right now, can't I? Okay, I do my usual, cancel my 3. 2 times 2 times 2 times 2, that's 8 times 3, 24 over 29. I'm done. Now, I spent a minute doing this. Just with pencil and paper, you should be able to do this very rapidly. Okay. People have paper? Just want to give you a couple. Give it a try. If you have paper, good. If you don't have paper, maybe next time. Let's try 77 over 132. Just let me know when you're done.
Do you want to factor to the smallest numbers? Factor to the smallest numbers?
Yeah, well, I want to know what the factors are so that I can reduce it to the smallest numbers.
So I have, for the top one, I have 7 and 11. And then for the bottom, I have 3, 11, 3, and 7.
Okay, I think,
Did I do something wrong?
well, you're definitely right that there's an 11 here. I don't think there's a 7 though. Am I wrong? 7?
No, maybe, let's see.
Yeah, I don't think there's a 7.
26.
see, 132 divided by 11, 22. So 11 and 2, is that right? So we get 7/22. There's actually a divisibility test by 11 too. You kind of know if the two digits are the same, it's divisible. But maybe this isn't that crucial. But if you add every other digit and you get the same thing, 1 plus 2 and 3, and you know it's divisible by 11. Doesn't mean it's not divisible by 11. Well, anyway. Okay. Just want to say, if you have difficulty with this kind of stuff, I suggest if you can, come to office hours. I can give you some hints on ways to get better at kind of the basic manipulation. There's some kind of practice things you can do, kind of like anything else you might want to practice, you know, hitting home runs, you know, how do you do that, right? There's some things you can practice on your own a little, and I can give you some hints on that. How many more minutes do we have? 4. Okay. Well, I'm going to stop here.